Alright, in this last video on lines, let's talk a bit about parallel and perpendicular lines. So recall from geometry that in a plane, that is any like two-dimensional space with length and width, two lines are parallel if and only if they do not intersect. What would that look like? What that would look like is, we know that the only way these lines cannot intersect eventually is if this one is basically, looks exactly like it, but exactly like this line, but kind of moved up or around. Similarly, two lines are perpendicular if and only if they intersect at a right angle. That is, what would that look like? That would look like something like this. Now, for the purposes of slope, it's not too hard to see that these two lines would have to have the same slope, them being parallel. Namely, two distinct non-vertical lines are parallel if and only if their slopes are the same. Namely, if M1 was this slope, M2 was that slope, M1 would have to equal M2. In a similar way, two distinct non-vertical lines are perpendicular if and only if their slopes are negative reciprocals of each other. Namely, if this was M1, how would we find the slope of this? Say it's M2. Well, it's negative 1 over M2 relates to M1. Okay, so negative reciprocal. For example, let's find the slope-intercept form of the equation of the lines that pass through the point 2, negative 1, and are one that's parallel to and one that's perpendicular to the line 2x minus 3y equals 5. Well, to start with, we have our point. We can use point-slope form, right? All we need is a slope, because it is called point-slope form, and we have a point. Here, this line, we want to know its slope. This line is the same thing as solving out for y, we can get the slope. Negative 3y equals 5 minus 2x, which is y equals, divide both sides by negative 3, you'll end up with positive 2/3 x minus 5/3. Okay? Doing that, so that is our line. So in other words, this is my slope, right? 2/3. Well, so now I have a point, I have a slope, so now I can find both the parallel and the perpendicular line. For A, I have a slope of m equal 2/3 and the point 2 comma negative 1. So I can use point-slope form. Y minus negative 1 equals 2/3 times x minus 2. Well, now we do our simplifying. X plus 1 equals 2/3 x minus 4/3. Add 1 to both sides, 2/3 x. Adding 1 to here would really be adding 3 over 3, so negative 1/3. What about the other side? For B, our slope is the negative reciprocal of this. So m equals 1 over negative 2/3. Well, that's going to be negative 3/2, right? Because reciprocal always flips whatever in the denominator. So, negative 3/2, and we still have the same point, right? 2 comma negative 1. So, using point-slope form, we get y minus negative 1 equals 2/3, negative 3/2 x minus 2. Y plus 1 equals negative 3/2 x. The 2 and the 2 would cancel, so plus 3 because distributing the negative. Subtract 1 from both sides. Y equals negative 3/2 x minus plus 2. Of course, you could actually check these by graphing them as well and seeing that this actually does create lines perpendicular and parallel to that. Now it's time for you to try an example, so go ahead and run the same problem that I did before, except this time through the point negative 4 and 1 and the line with the line 5x minus 3y equal 8. On the count of 3, I'll reveal the solution. 1, 2, 3. And so you see here that I went ahead, this is the parallel line, this is the perpendicular line. What you'll notice here is I actually did go ahead and graph this line. I went ahead and graphed that line. And then the red line is the perpendicular line that goes through that point. This is the parallel line that goes through that point. And so as you can see, using these equations, you actually do get the correct solution. For more practice in working with parallel and perpendicular lines, be sure to see pages 31 and 32 of the textbook and work problems number 4, 5, and 65 through 80. In our next video, we'll finally start talking about functions.